So this lesson is all about solving by completing the square, but this time the equation has some type of a transformation like a stretch applied to it. In other words, the leading coefficient is not 1. So let's take a look at one of these. Let's do 2x squared plus 10x minus 3 equals 0. Okay, so the first step you want to do here is just divide everything by 2. That's going to make it much easier to solve. So 2x squared divided by 2 is x squared. 10x divided by 2 is 5x, so plus 5x. And then negative 3 halves, that does not simplify, equals 0 divided by 2, which is 0. Okay, next step, I'm going to add this 3 halves to both sides. I'm trying to isolate the x squared so then we can do the perfect square trinomial. So plus 3 halves to both sides. So x squared plus 5x equals 3 halves. So now we need to figure out the number that goes here. What you do is you take this 5, divide it by 2, and then square it. So that equals 5 squared divided by 2 squared, or 25 divided by 4. Okay, now we're going to have some fun. So x squared plus 5x plus 25 fourths equals 3 halves plus 25 fourths. The left side can be written as a binomial squared. It's going to be x plus 5 halves squared equals, then we need to do a common denominator here. So 3 halves equals 6 fourths. So I'm going to do 6 fourths plus 25 fourths equals 31 fourths. Now I'm going to take the square root of both sides, plus or minus there. So x plus 5 halves equals plus or minus the square root of 31 fourths. Next step, subtract 5 halves from both sides. So x equals negative 5 halves plus or minus square root of 31 fourths. And the square root is for the whole thing. I'm going to rationalize the denominator here for the 31 fourths. Actually, 4 is a perfect square, so that's the same thing as square root of 31 over 2. You just square root the 4. So here's your solution. X equals negative 5 halves plus or minus square root of 31 halves. And that's two solutions, negative 5 halves plus square root of 31 halves, and negative 5 halves minus square root of 31 halves. This is an exact solution. And this is a good example of why completing the square is a good method. I mean, the fractions were a little ugly, but look at this nice solution it gives you. It's all simplified and good to go. So that's what you're going to be working on this lesson, is completing the square. And remember, just divide by the leading coefficient first, and then it's just like the other ones you've been doing. So that's the big picture.